5e, block of mass 100 kilos, dragged up a smooth slope. It's important, no mu. Where tan A is 4 over 3. Okay, well, let's just do that real quick. Tan A is opposite over adjacent, so cos A is A over H, 3 over 5, and sine A is O over H, 4 over 5. We will need these at some point. So let's do our diagram. The pulling force is 984, and we're asked to find the acceleration. Okay, so diagram here. So I've got my block of 100 kilos. So it's going to have a force towards the center of the earth of 100 G. I have an angle A here. I'm going to just make a big line down here to separate them. So I've got my angle A here. So this side here is 100 G cos A, which is equal to 3/5 of 100, which is equal to 60 G. And then we have this guy, which is 100 G sine A, and that's 4/5 or 80% of 100 G, which is 80 G. It's getting dragged up. Now, sometimes it can go in this direction. We've seen these before. So I have tension in the rope, and I'm told that the tension or the force is 984. So I'll write my equation out anyway. I'll stick my R in as well because we do have a second part to this question. So it's going up the slope, so we're going in the direction of T. So T minus, and this guy is the only guy going down in the opposite direction. T minus 80G is equal to M. And we call acceleration A. We didn't write acceleration A, but let's write acceleration A. So we're looking for A, and in fact we have T is the force that was going 984. So 984 minus 80 by 9.8, and that we divide that by 100. We're going to get A. So the acceleration is equal to, it's going to give me 2, exactly 2 meters per second squared. We're also then told that if the coefficient between the block and the slope was a third, what would the acceleration be? Okay, so let's have a look now. It's getting dragged up the slope, so there's mu r going back here. We can say r is equal to 60G. R is equal to 60G. So mu r is equal to a third of 60G, which is 20G. So there's now 20G opposing it. So instead of T minus 80G, we're going to have T minus 100G minus 80G minus 20G is equal to 108. So T minus 100G is equal to, I wrote G here, is equal to 108. So what was my 984 minus 100 by 9.8 is 980 is equal to 108. So 4 over 100 is equal to A. So A is equal to 0.04 meters per second squared. So let's have a look at question 2. A particle of mass 3 kilos. We have an angle A and we have a mass of 10 kilos. And we're told sine A is a third. Sine A is a third. Okay, we'll get cos A if we need it. And nothing else unusual in this question. No mu, it's a smooth plane. And we're asked to find the common acceleration and the tension, and it's going to be in terms of G. Okay, so let's draw these diagrams, our 3 and our 10. So we have our 3 and we have our 10, and they're connected by this pulley. We have A, so going to have an A in here. So if we take the 3, we'll put it on the slope and take it out separately. So in this direction we have 3g. In this direction I have 3g adjacent to A, cos A, and in this direction here I have 3g sine A. We were told sine A was equal to a third, so that's going to be just g. We have my reaction in this direction, and it's a smooth surface, and we have a string going in this direction. So if we resolve my forces, I can say that T minus G, my T is going in this direction, minus my G going in that direction. T minus G is equal to MA 3, and we didn't put our acceleration in, going up the slope, 3A. For my 10, I have 10G. I have tension in the string. I have my acceleration going down. So 10G minus T, resolve the forces, and that's equal to MA 10A. If I bring my other equation across, I can write minus G plus T is equal to 3A. So I get 9G is equal to 13A. So A is equal to 9G over 13 meters per second squared. And we want to find T as well. T is equal to, from here, T is equal to 3A plus G. T is equal to 3 by 9G over 13, 3A plus a full G. So my tension is 27G over 13 plus 13G over 13, which is 40G over 13, and that's in newtons. Okay, next video for 3 and 4.